Hello, sciences lover, and welcome to our new video lesson. After our first introductory course on linear regression, today we will practice simple linear regression in Python. Our goal during this tutorial is to learn how to make a prediction using a linear model. Okay, let's start with a quick recap of what we've learned so far, what linear regression is, and how to make a prediction with it. The regression model is y equals b0 plus b1 times x. In this model, the b0 and b1 are coefficients. These coefficients are what we need in order to make predictions about our y. To perform all the steps in this tutorial, we need to install Anaconda and launch Spider. If you don't know how to install and launch them, let us know in the comments and we'll make a tutorial to guide you through those steps. We use two Python packages, NumPy and scikit-learn. NumPy allows many high-performance operations on single and multi-dimensional arrays. Scikit-learn will provide us with the tools we need for implementing regression. Okay, there are 5 basic steps we need to take to implement linear regression. 1. Import the packages and classes we need. 2. Provide data to work with and eventually do appropriate transformations. 3. Create a regression model and fit it with existing data. 4. Check the results of model fitting to know whether the model is satisfactory. 5. Apply the model for predictions. To import the package NumPy and the class linear regression from sklearn.linearModel, you need to write the following codes. Okay, I am importing NumPy, and I'm going to call it NP in this project. NP is just a shorter name for NumPy that I'm going to use in this project. You can choose any name that you want. The next thing that I'm going to do is to import the class linear regression from the package scikit-learn. After running the codes, you have all the functionalities you need to implement linear regression. The second step is to define data to work with. In this tutorial, we simulate our data using the NumPy function called random.random. You can also download your own real data instead if you want to. I've chosen the simulation because I need to be sure that the relation between x and y is linear. Don't forget, the linear regression is only used when the relation between x and y is linear. In order to use the linear regression functions, the independent variable x and the dependent variable y should be arrays or similar objects. This is the simplest way of providing data for regression. All right, now let's simulate x and y like this. Y is linearly related to x. So we have two arrays here, the input x and output y. We should call .reshape on x because this array is required to be two-dimensional, or to be more precise, to have one column and as many rows as necessary. That is exactly what the argument -1, 1 of .reshape specifies. Random.seed gives the same starting point called seed for the simulation. It's not required, but if you choose the same seed as I've chosen, and it is 0, you will obtain the same result. If you change it, you change the entire simulation, and the result will be different. This is how x and y look like. As you can see, x has 2 dimensions, and x.shape is 30 times 1, while y has a single dimension, and y.shape is 30 times 1. The next step is to create a linear regression model and fit it using the existing data. So let's create an instance of the class linear regression, which will represent the regression model. This statement creates the variable model as an instance of linear regression. We can provide several optional parameters to linear regression. Now, it's time to start using the model. First, you need to call the fit function on the model. With the fit function, we can estimate the regression coefficients b0 and b1 using the existing input and output x and y as the arguments. In other words, the fit fits the model. Once we have our model fitted, we can get the results to check whether the model works satisfactorily and interpret it. In linear regression, one way to measure the accuracy of the model is by using the R-squared. It is the share of total information on y explained by x. The closer it is to 1, the higher is the accuracy of the model, and the better x predicts y. In our case, for example, the R-squared is 0.93, which is very close to 1. Do you know why? Okay, I'll explain it to you. We simulate y based on the value of x, so the relation between x and y is close to 100%. It would be 100% if we didn't add the random value in the y simulation. We can say that we have a satisfactory model. Now, the coefficients b0 and b1 are obtained with the function model.intercept and model.coef. These codes illustrate how to get b0 and b1. You can notice that .intercept is scalar, while .coef is an array. b0 equals 2.50 illustrates that your model predicts the response 2.50 when x is 0. b1 equals 2.91 means that the predicted response rises by 2.91 when x is increased by 1. We can say that we have a good interpretation of our model. As we have a satisfactory model, you can use it for predictions with any new data. In practice, regression models are often applied for forecasts. It means that you can use fitted models to calculate the outputs based on some other new inputs. Here, predict is applied to the new simulate data x new and yields the response y new. We use random.random from NumPy to generate an array with the new data and predict a new corresponding y. That's it. Now you know exactly how to make your simple linear regression model in Python. If you enjoyed this video, please like it, share it, subscribe to our channel, and click on the notification button so you can receive a notification when our next course is ready.